Prepare yourself for an unprecedented cosmic catastrophe. The red giant star Betelgeuse, perched on the edge of our galaxy, is warning everyone in the universe of impending danger. Astronomers have discovered something quite unnerving about this enormous celestial entity using the James Webb Space Telescope. Renowned astronomer Brian Cox raises a serious alarm, raising the question, could we be about to experience a supernova explosion that will completely alter the night sky? Now, let's get started. One star in the vast fabric of the universe, where stars are born, grow, and die in spectacular ways, has recently drawn the attention and concern of both the general public and scientists. This star is Betelgeuse, a massive red supergiant prominently located in the constellation Orion. It is enormous in both size and age, long mysterious due to its unusual reddish color and fluctuating brightness. Curiosity in the celestial giant has increased recently. We are at the brink of a potentially historic event in the star's life cycle as we investigate the nature of Betelgeuse. But what can these Betelgeuse modifications mean? Are we seeing the beginning of an unfathomably grand cosmic spectacle? Betelgeuse is a massive star, roughly 764 times bigger than our Sun. Its enormous immensity is nearly unfathomable to humans. Imagine a star so massive that it would swallow up Mercury, Venus, Earth, and Mars in its stellar embrace if it were to replace our Sun, extending its surface beyond Mars' orbit. This extraordinary size indicates Betelgeuse's position in the stellar life cycle. In addition to its physical characteristics, Betelgeuse is a red supergiant nearing the end of its life. This phase is marked by expansion and cooling after the star's core underwent a life of fusing hydrogen and helium. However, what about Betelgeuse's age? This star is relatively young in human terms, yet it is ancient in terms of stellar lifetimes, with an estimated age of 8 to 8.5 million years. Millions of years of evolution have culminated in its current red supergiant phase, during which time it has undergone numerous dramatic changes and processes that have shaped it from a hot blue star to the red giant we see today. Nuclear fusion and gravity are two processes that propel stars like Betelgeuse through a life cycle of constant change. Another distinguishing feature of Betelgeuse at this stage is its characteristic reddish color. Its surface temperature is comparatively lower than that of other stars, like our Sun, which gives it its red hue. Betelgeuse's cold surface records temperatures of roughly 3,500 Kelvin, compared to the Sun's surface temperature of approximately 5,500 Kelvin. Betelgeuse appears red because of the wavelengths of light it emits due to its lower temperature. This star's color, however, tells us much more than simply how it looks. It also tells us something about the activities going on inside its enormous gaseous expanse and its physical state. Betelgeuse's historical color shift adds to its enigmatic nature. It is suggested in ancient Roman and Chinese texts that Betelgeuse was yellow around 2,000 years ago. The first accounts of it being red came from Arabic academics only in the 9th century. Not only is this color change a minor detail in the history of astronomy, but it also provides insight into the star's evolutionary history. Another interesting feature of Betelgeuse is its fluctuating brightness. Because it is a semi-regular variable star, its light varies on a periodic basis. For generations, astronomers and skywatchers have been captivated by this distinctive dance of luminosity. Betelgeuse typically travels through two cycles, one lasting 400 days and the other lasting roughly 5 years. According to Sir John Herschel's 1836 documentation, these cycles may have existed earlier in Aboriginal oral tales. However, Betelgeuse's irregularity, rather than just its fluctuating brightness, is what really makes it mysterious. Betelgeuse, in contrast to many stars that exhibit a regular pattern of brightness and fading, occasionally deviates from this pattern, suggesting intricate and poorly understood processes taking place within its massive structure. In a recent groundbreaking discovery, Betelgeuse unexpectedly and dramatically changed in appearance, an occurrence that has come to be known as the Great Dimming, which attracted the attention of scientists and stargazers worldwide. One of the brightest stars in the sky and a main component of the Orion constellation, the red supergiant Betelgeuse started to strangely fade in late 2019. The star's fading was so severe that it started to lose brightness at a daily average of 0.01 magnitudes, and in February 2020, it reached its lowest brightness. Even amateur viewers could see that Betelgeuse, which is typically visible with the unaided eye in light-polluted locations, had become noticeably fainter. The time paradox presents a challenge when attempting to keep an eye on Betelgeuse's activities, though. Because of the time it takes for light to reach us, when we gaze at a star like Betelgeuse, we are not viewing it as it is in the present but rather as it was in the past. In the instance of Betelgeuse, the light we see today departed the star about 7 centuries ago, at a distance of about 725 light-years. Because we are effectively looking into the past of the star, this temporal lag makes it difficult to forecast and track abrupt changes in its behavior. The Betelgeuse dimming incident acted as a reminder of the challenges that come with doing real-time astronomical observations, as well as the boundaries of our knowledge when it comes to handling the enormous cosmic scales and the temporal paradox they create. Associate Director of the Center for Astrophysics at Harvard and Smithsonian, Andrea Dupree, and her team kept a careful eye on the unfolding of Betelgeuse's cosmic drama. They examined the massive star using Hubble as part of a 3-year project to track changes in Betelgeuse's outer atmosphere. These observations provided a unique window into the dynamics of Betelgeuse, a variable star whose brightness fluctuates due to periodical expansions and contractions. Researchers were able to examine the layers above the star's surface, which were partially heated by the star's chaotic convection cells, thanks to Hubble's sensitivity to ultraviolet light. Additional examination of the Hubble spectra obtained at various intervals in 2019 and 2020 aided in quantifying the flow of material in Betelgeuse's outer atmosphere. The magnesium-2 lines, in particular, which are suggestive of the star's atmospheric circumstances, were the focus of the spectra. According to these observations, material was leaving the star's surface and entering its outer atmosphere at a speed of almost 200,000 miles per hour. Millions of kilometers eventually separated this hot, dense material from Betelgeuse, and it served as the forerunner of the dust cloud that caused the star to fade over the course of the 3 months following the eruption. Dupree and her team calculated that roughly twice as much material from Betelgeuse's southern hemisphere was lost as usual. Given that Betelgeuse, like all stars, regularly loses mass, albeit at a rate substantially higher than that of our Sun, this mass loss was noteworthy. Astronomers debated if this mass ejection's magnitude and the ensuing darkening indicated if it was a possible precursor to a supernova explosion. The mystery is increased by Betelgeuse's close proximity to Earth, roughly 725 light-years away. Any explosion of that kind would be visible from Earth and offer a unique chance to see a supernova up close. However, the question still stands: what does Betelgeuse's future hold in store for this dimming event? Is it a sign of a coming supernova, or just a singular event in the lengthy and intricate life of the star? Numerous hypotheses were put up to account for this abrupt shift. Due to the widespread perception that Betelgeuse is approaching the end of its life, one popular explanation proposed a stage in the supernova explosion process. Another common explanation was that our perspective was obscured by dust, possibly from the star itself. It was believed that the material that Betelgeuse, like other red supergiants, sheds could create a dust cloud that is dense enough to block off light from the star from Earth. A third theory examined modifications to the star's photosphere, or visible surface layer, which might have an impact on how bright it appears. This enigma was solved through in-depth investigation employing a variety of observational techniques. The effective temperature of Betelgeuse decreased, as revealed by spectroscopic measurements, indicating that a sizable dark area on the star's surface may be the cause of the dimming. The fact that Betelgeuse's temperature decreased by at least 170 Kelvin at the time of the dimming, indicating major surface changes, confirmed this notion. Ultimately, the Hubble Space Telescope, humanity's space sentinel, provided the key to comprehending this peculiar occurrence. According to Hubble's measurements, a huge ejection of hot material into space is most likely what caused Betelgeuse to darken. This stuff created a dust cloud that covered part of the star's surface, decreasing the quantity of light that Betelgeuse was able to send our way. It was thought that superhot plasma, which burst from a massive convection cell on the star's surface and traveled through its heated atmosphere to the star's cooler outer layers, was what created the dust cloud. Roughly 25% of the star's surface was darkened by a cloud created by the solidification of dust grains as the star cooled. Beginning in January 2019, Hubble's ultraviolet light spectroscopic observations were essential in assembling the sequence of events before Betelgeuse's darkening. In the months before the star's brightness decreased, these observations detected dense, heated material moving through Betelgeuse's atmosphere. Betelgeuse darkened as this hot plasma passed through the outer layers, cooling into a huge dust cloud. According to recent observations made by astronomers, Betelgeuse is already showing signs of rebounding. Betelgeuse's light began to gradually recover in the middle of February 2020, suggesting that the darkening was caused by a thick cloud of dust. Although the nature of the star's fluctuation and the likelihood of more eruptions in the future remain unknown, this discovery provides some comfort. However, the inquiry into Betelgeuse's secrets is still ongoing. Although astronomers have found some solutions, the star still raises important concerns regarding its future behavior, the possibility of future supernova explosions, and the general behavior of red supergiants at this stage of their existence. As for Betelgeuse, the star is still present in the sky, a massive, enigmatic force whose destiny is intricately intertwined with the vast fabric of the cosmos. Future observations might provide more details about the star's internal workings, its ultimate demise, and the part it plays in the larger cosmic picture. We may be in for a front-row seat to one of the most dramatic events in the universe if Betelgeuse is indeed getting ready to go supernova. Although Betelgeuse is not currently expected to go supernova, its behavior is an urgent reminder of the dynamic and unexpected nature of the cosmos. The story of Betelgeuse serves as a reminder that the cosmos, in all of its grandeur and majesty, still holds many mysteries.